Hi there. The last 2 weeks we've looked at two forms of quadratic functions. We've looked at standard form and factored form, and this week we're going to look at our third form, which is called vertex form. So before we fill out these notes, I actually want to play around with vertex form a little bit on Desmos. That's what I would normally have you do. Of course, this isn't really normal times. So check out, I've got vertex form right here in this equation editor. It looks like y equals a times x minus h squared plus k. So it looks pretty different than any of the other two forms we've looked at so far. The only thing that they seem to have in common is this a value. The new things here are this h and this k, and I think the structure of it is kind of funky as well. So let's explore just a little bit. And let's look at this a value. We know that the a value in both of our other forms, standard and factored form, tell us about what direction the parabola opens, right? If a is positive, our parabola opens upward. So I'm going to change this and look at those positive values. And if a is negative, our parabola opens downward. So it looks like that a value is doing the same thing here. Now, it's also affecting the shape of the graph. When the a value gets really big in the negative direction or really big in the positive direction, that parabola gets skinnier and skinnier and skinnier. If we were to make it a decimal, something that's between 0 and 1, right, it gets wider. Also between 0 and -1. So our a value is pretty consistent with what we've seen before, so we might not have to worry about that as much. What's really weird are these h and k values. So let's explore them one at a time. So right now I've got h is 0 and k is 0. And let's check this out. This looks like our basic parabola. It's got a vertex at 0, 0. It's opening upwards. Now if I change the h value, so if I move it in the positive direction, what's happening? It looks like the parabola is moving to the right. If I move h to the negative direction, the parabola moves to the left. And if I take a closer look at that vertex. Check it out. That vertex actually matches my h value right there. It's at -5.7. Also turns out it matches that k value of 0. So if h moves the parabola to the left and to the right, what's k going to do? K will move the parabola up and down. So again, if I take a close look at that value, I can click on that vertex. -3.6, -3.6. Now, what if I wanted to make my vertex over here at, let's say, the coordinate point 3, 2? Well, if I move my h value to 3, and my k value to 2, almost, there we go. Now my vertex is exactly where I said I wanted it to be. It's at 3, 2. So vertex form, and it's kind of in the name, vertex form tells us the location of the vertex. So specifically, vertex form looks like, y equals a times x minus h squared plus k. So our our h value, I'm just going to highlight that, our h value is the x coordinate of the vertex. And something to point out here, look, it's got a negative in front of it. It's got a minus sign in front of it. That's built into the equation. So we're going to actually have to use the opposite sign of what we see here. We saw that when h was positive, it moved to the right. But if we had a positive number as h, it would look like a negative number because of that negative that's built in. So be careful there. Our k value is the y coordinate of the vertex. That one's pretty straightforward because it's got just a plus right next to it. We get to use the exact same sign. So the only real tricky thing to here is that with H we use the opposite sign, with K we use the same sign. Now the way I remember which one goes with the X coordinate and which one goes with the Y coordinate is that H is tucked inside those parentheses with X, right? If it's tucked with X, it goes with the X. If it's on the outside, it's going to go with the Y. And then that A value, we already know, tells us about the shape of the graph. So if A is positive, the parabola opens upward. If A is negative, the parabola opens downward. And again, we could have those little visualizations there. And if let's say the absolute value of A is bigger than 1, so if it's a bigger positive number or a bigger negative number, the graph will be skinnier or narrower than y equals x squared. We haven't talked about this as much, but I think it's just one more thing we can add. And if the absolute value of A is less than 1, so something between -1 and 1, right, a decimal there, the graph will be wider. So just like last week, we're going to practice looking, not just last week, but the week before too. We're going to use this form to practice making a graph and talking about all those key features that have become so important here. So just some first examples, we want to identify the vertex of each of the following quadratic functions. And notice that the A value doesn't impact the vertex at all. All we look at are the H values and the K values. So based on this, we've got x minus 6 squared plus 7. So our H value is 6 because we use the opposite sign. And our K value is 7. We use the same sign. So that will be our vertexes at the point 6, 7. For the second example, again, we've got it negative x plus 3 squared plus 9. So that means that A value is -1. But again, it doesn't impact the H and the K value, the vertex at all. So again, we're using the opposite H value. So since I see plus 3, my X coordinate will be -3. And plus 9 for K means that my Y coordinate will be 9. Last example here, again, just practicing just finding the vertex. 0.5 times x minus 7 squared minus 1. Our vertex will be at the coordinate point 7, -1. So opposite as what's in there, same as what's out there. So we've done graphing before, and something that I think we were missing from the last few weeks was just a little bit of structure. I was kind of throwing a lot of points at you guys without really helping you make structure of it. So my graphing pro tip here, a little bit late to the game, but better late than never, is to use a table of values. And when you're making a table, find the vertex first. Start with the vertex, and then pick the x values that are around it. So think of the vertex as the middle of your parabola, right? If it's the middle of the parabola, it should also be the middle of your table. So that's going to be our strategy here. So the equation that we're graphing, we are graphing y equals x minus 3 squared minus 4. So our vertex here is opposite of h, positive 3, and -4 for our x and y values. So I'm going to put my vertex 3, -4, right here in the middle of my table. All right, this is my vertex. So I'm going to put it right here in the middle of my table. I could also graph it. I think that's a good start. 3, -4. And so I'm going to pick the x values that are above and below 3. If I know that the parabola is going to be centered around this vertex, my x values are going to be centered around 3. So I'm going to use 4, 5, 6, and then work backwards. 2, 1, 0. And so this will help me decide which x values to use, which ones to plug in to help me find the rest of my coordinate points. Now, as I'm plugging in points, there's two things to remember. First is that the axis of symmetry says if I find one point, I get another one for free. Love it, buy one, get one free. The other thing is I need to follow the order of operations. So that's why I left this space in the middle to really see how we do that. So if x is 0, I'm going to replace my x in my equation, whoops, that's the power of 2, with 0. So that's all I did was I took this x value and I replaced it with this x value here. So order of operations says, parentheses first, 0 times -3 is -3 squared minus 4. Now -3 squared, if you're doing this in your calculator, you have to use parentheses. -3 times -3 is +9, not -9. Be careful. 9 minus 4 is 5. So I get a coordinate point of 0, 5. And I also get another coordinate point for free, right? On the opposite side of the axis of symmetry would be the point 6, 5. And so keeping everything organized in the table allows me to see that. So I have 0, 5, and 6, 5. Now I'm going to end up with 7 points here. I told you earlier you only need 5 points for your parabola, but that's okay. So I'm just going to repeat this process, replacing the x values with the x values from my table. You don't have to do this by hand, right? You could just plug this expression into your calculator. But I think it's important that we just remember how that mental math works with the order of operations. So -2 squared, that's +4, minus 4 is 0. So you get the point 1, 0, and we get its buddy over here, 5, 0. And then last but not least, I'm going to replace x with 2. And 2 minus 3 squared, that's -1 squared. -1 times -1 is +1. And +1 minus 4 is -3. So I get 2, -3, and 4, -3 is my other point. So like I said, I should have included that in our notes a couple weeks back, but I don't have a time machine, so I'm including it now. Using a table of values to not only organize your work, but organize your thinking as well, and putting that vertex right smack dab in the middle. So I have 2 more examples here. I think we only need to do maybe one example together, and then the second example, or excuse me, the third example, I'll have you do, and I'll have you check your answers with me. So example 2, negative x plus 2 squared plus 4. So we're going to start with our vertex, finding our vertex. This is vertex form. So we need our h and our k values. Well, opposite of h here we get, or opposite of what we see, that'll be -2. And then our k value is exactly what we see, so -2, 4. And I'm going to put that right in the middle of my table, right? My vertex goes right in the middle of my table. So I'm also going to plot it just because I like doing that, -2, +4. Now this a value is -1, so we have to keep that in mind. We know that tells us that our parabola will open downwards, and that's just something good to check. So some x values that are around -2, we could have -3, -4, -5, -1, 0, 1. So you can choose either set, either the ones above -2 or the ones below -2. But we're going to do that same process. And instead of minus right here, I'm going to write it as a -1 so that I remember exactly what that is that I'm doing. And then I'm going to replace x with the x value from my table. So in this case, that x value I was replacing was -1, and that -1 went right there. There's a couple -1s in there. I didn't want us to get confused. All right, so order of operations, again, parentheses first. -1 plus 2 is +1 squared. 1 squared is 1. times that -1 makes it -1. So I kind of did 2 steps at once there. And again, at any point you could just use your calculator. It's not better, it's not worse, it's just a tool, right? Don't worry about, oh, Miss Swampold did it by hand with the order of operations. Who cares? So same process though, and I like writing out my work here just so that I can see exactly what it is that I'm doing. So that if I make a mistake, and mistakes will happen, some of you will make some very funky looking graphs, and just know it happens. If for some reason your graph comes out looking not like a parabola, that just means that you miscalculated something. It happens, and you can check it. That's what we do when we make mistakes, right? We fix them. So one more x value. Remember, I don't have to plug in 7 x values. I can plug in just a few and get some for free. 1 plus 2 squared, that'll be 3 squared. 3 squared is 9, times that -1 is -9. And then that'll give me -5 as my y value. -5 as well. And so I can graph my parabola here. Oh no, okay. Pretty close. Yours will look better than mine, I hope. So from here, I can, I already know my vertex, -2, 4. My vertex is at the top of my graph, so it is a maximum. My y-intercept I found along the way. It is 0, 0, right there where it crosses the y-axis. My x-intercepts, there's actually 2 of them. One is going to be at -4, 0, and the other one is at 0, 0. It's okay to use that point twice if it happens to be both an x-intercept and a y-intercept. Our domain here, this is a parabola. I put arrows at the end. This will be all real numbers. And then my range, because this graph hits hits 4, right? It's like there's an invisible boundary here where it goes up to 4, and below that, doesn't go above that. Our range is going to be y is less than or equal to 4. So, again, just another example of the whole process here. So for this last example, I'm going to have you maybe pause and do it in parts as I ask you some questions. And then you can check your answers, see how it goes, and follow up with Zoom or email if you have any other questions there.